All right, so welcome to Natural Language Processing in Python, Part 1. So this is going to be a multi-part series on this subject. How many parts? I'm not exactly sure. I'm writing these tutorials as I go, so I've completed the content necessary for Part 1, and I'm just going to record a video for that and upload it, and as I continue to write more, I'll upload them accordingly. The number of parts that will be uploaded will probably depend on interest. So depending on comments that I get, if there's more interest to see more natural language processing, there'll probably be more videos on the subject. And also based on, I guess, the content that will be useful to cover. So I want to get to a point for you to learn enough natural language processing so that you can build your own projects, you can be dangerous enough to use it for your own purposes, and hopefully can learn something along the way. So with that said, I'm going to mention that every video in this series will have an accommodating blog post. So this blog post will be associated with my blog. I'll leave a link to this in the description below. And the blog post will consist of a link to the video and some other supplementary information, mostly focused on what the video covers. So if you want more context or information about what we will cover in this video, you can look at the blog post to consult that. I will also post all of the code for each video on my GitHub page, as I usually do for all of the other videos as well. So I'll leave a link to this in the description below. This is the code that we'll be covering in this video. And as I continue to write further tutorials on natural language processing, they will all be found in this folder here with the name NLP underscore whatever the number of the video is that I'm currently recording. So in this case, it's the first one, so it's 1. So all the code will be available here for you to download and use, and that is that. So with that said, let's go ahead and get started with getting you up and running with natural language processing. So I'm going to assume that you have Python installed on your machine. And I'm not going to assume that you have what's called NLTK, which is a Python module that we will be primarily using for natural language processing. Okay, so with that out of the way, let's go ahead and get started to install what we require to proceed. So the first thing I'm going to assume is that you have Python installed on your machine. And if you do, the only module that we'll be requiring in this is the NLTK module, which stands for Natural Language Toolkit. So you can install that using the pip command. All you have to do is open up a terminal and type in pip install NLTK. So I've already got this installed on my machine, so I'm just going to see requirement already satisfied. Of course, if you don't, you'll see some installation happening on your machine. Once you've got that, there's one other thing that we'll need to do, and that is to download a collection of text that NLTK provides to us. So this collection of text is just a huge database of different types of text like books or chat logs. And the nice thing about this is we can use these text examples to run some natural language processing commands on. And it's really nice just because all of this stuff is able to be directly loaded via the NLTK module, and it's very easy for us to just load this in and then do some interesting stuff on this content. So what you're going to want to do is either open up a Python shell or write this to a Python file that is import NLTK, which is the module we just downloaded, and then run the following command, which is nltk.download. So if we go ahead and run this, what you'll see is you'll run this and a dialog box should pop up. So this is the NLTK downloader. So right now on this, you'll see this is all green. That's because I've downloaded all of this content. If this is the first time you're seeing this, this will probably be either yellow or red. What you're going to want to do, or what I recommend you do, is you download all of the packages. So just go ahead and keep this highlighted on all and hit the download button. So this can take a couple minutes because the text database is quite large. It's not going to take too long, depending on your internet connection. But once you have it all downloaded, if you do that command again, run it, you should see that this is all green. You don't have to have everything downloaded, of course, but it does provide a lot of really useful and interesting text information that will be very handy to just kind of have as a playground for natural language processing. So I'm just going to go ahead and close this since I have it installed and get back to the Python script here. Okay, so now that we've downloaded all of that text, I'm just going to go ahead and comment this line out so we don't have to worry about that, and we're going to proceed on to some rudimentary natural language processing. So now that we've downloaded all that, what I'm going to do in this video is just really focus on processing the text of a single book, which I've chosen to be Alice in Wonderland by Lewis Carroll. You can choose any book or text that you like. I guess to follow along exactly with this tutorial, you can just follow along with exactly what you see on the screen here, or on the GitHub repository in the link below in the description. So what I'm going to be doing is, first on line 52 is I'm going to load in this text function from NLTK, and then I'm going to store in the Alice in Wonderland text into a form that NLTK can understand, and I'm going to store that into this variable Alice. So let me describe a little bit more about what's going on here. So inside this text function, we have this line here. So NLTK provides an API, in some words, to Gutenberg, Project Gutenberg, which is a website that allows you to access public domain books. So books that are quite old, usually, that are freely available. One of the books that are in the public domain is Lewis Carroll's Alice in Wonderland, and we're using NLTK's ability to grab these texts, and I'm going to load them in so we can process them. And then I'm wrapping that all in this text function. The text function is essentially taking any piece of text, in this case, this Alice in Wonderland piece of text, and it's breaking it into tokens, or it's making it readable by NLTK so we can actually do some natural language processing on it. And then we're storing that in this variable Alice. So we're going to use this variable Alice throughout the rest of this video tutorial. So if you'd like to see other works that Project Gutenberg provides that you can read in, if you don't want to do this with Alice in Wonderland, you can print out a list of the other works available from this Gutenberg API. So I'm going to go ahead and write this and run it. And if I run it, basically what I'm going to see are a list of, and there's also some plots here. I'm going to see a list of things here, which are other works that you could also read in. So there's a lot of Shakespeare, there's some Austen, there's the Bible, a couple other ones that you might be more interested in reading and processing on your own. In fact, I encourage you, if you'd like to, go ahead and read in another piece of text and do some of these things that we're doing in this video to see if you can kind of get your hands dirty and do something that's slightly different from what's in this video. So with that said, I'm just going to comment this line out here so we don't see that pop up every time. Let's see here. There we go. So now that we have this all loaded in, let's go ahead and just do some very rudimentary natural language processing things on the NLTK text object that we've loaded in here. One of the things we can ask is the word count. So how many words, more specifically in this context, how many tokens are present in Alice in Wonderland? So what I'm going to do is you can just print out the length of Alice. So this is similar, if you are familiar with Python, you can print out the length of a string, and that will give you the number of characters in that string. This length function has been overloaded to work on an NLTK text object, which will allow us to get what you would expect, in this case, the number of words or tokens in the text Alice in Wonderland. And just to kind of hammer that point home, let me print out the type of Alice. We're not taking the length of a string, we're taking the length of the Alice object, which is an NLTK text object. So the length function has been overloaded to work for this particular object. So I'm going to go ahead and run this code. So as I mentioned, the type of the type of Alice is an NLTK text object, and an Alice in Wonderland consists of 34,110 characters, words rather. So that's kind of interesting. That's a little bit of a 20,000 or so foot view of what we can ask. We can also ask some other questions that are related to that one as well. Let's ask a few more, I guess, more interesting questions. So one we can ask is how many unique words are present in Alice in Wonderland. So we had a count of 34,000 plus words in Alice in Wonderland, but perhaps we don't care about how many times the word the or and or some of these more common words occurred. If we just see it once, that's enough for us to check it off the list and never count it again. So again, we can do something that's quite Pythonic, and we can just say print out the length of the set of Alice. So if you're not familiar with what the set built-in Python function does, it essentially just takes something like a list, and it just gives you all of the unique elements of that list. In this case, it's giving us all the unique elements of this NLTK text object, and then we're taking the length of that, and then we're just printing that out to the terminal. So let's go ahead and run that, see what we get. So of course we get a smaller number, which makes sense because we're just taking the unique word count in this case. So there's 3,016 unique words in Alice in Wonderland. So let's go ahead and comment that out so that doesn't run every time. Another thing that we can ask, which again is quite Pythonic in the way that we can ask it, is a specific word count. So if I'm curious about how often a specific word occurs in a text, I can do the following line here, where I can just say alice.count and then give it a string, which corresponds to this is the thing that I want you to count, how many times it occurs in the text. So again, this is all Pythonic. There's nothing specifically going on here with respect to NLTK. Of course, it's operating on an NLTK object, but this should be familiar to you if you've done this on, say, a list, where you could do a very similar type of syntax where you'll do the list, the name of the list, dot count, and then you'll give it an argument, which is what you want to count. So in this case, we're counting the number of occurrences of Alice. So if we go ahead and run this, let's go ahead and run that there, we get that the word Alice appears 396 times. One other thing that we can ask, which is a little bit more focused on natural language processing terminology, which is the concordance of a word. So the concordance is really just show me the occurrence of the word and also give me the relevant context. So show me a little bit of the sentence in which the word occurs. So we can check the concordance of the word Alice by just saying Alice.concordance and then of course giving it the word that we want to determine the concordance of. So if we go ahead and run this, what we see is essentially a list, and each line of this list is the word that we're looking for. In this case, Alice. It's all nicely centered down the line here, and then it gives us a little bit of context. So this is the first line here. This is the second line here where we have Alice and a little bit of context on the left and the right. You'll notice too that we checked how many times the word Alice occurs. That's 396. And then for whatever reason, we're getting 398 here for the number of times that concordance is finding the word Alice. Well, concordance also determines here that Alice is a valid thing to look for in this thing. So it's basically figuring out like, oh, okay, here's Alice, and I'm going to tag on this apostrophe S, and I'm going to say that this is a valid occurrence of this word. So I'm going to show it and also the relevant context of this word, the concordance. So that's kind of neat. So let's go ahead and just comment that out. So let's move on along here. So another thing that we can do is we can plot some visual information, which is kind of interesting. And the thing that we're going to plot is something called a dispersion plot. A dispersion plot is going to show us the location of where a word is present in a text. So let's just take an example here that's relevant to Alice in Wonderland. Say we want a visual representation of the words Alice, Rabbit, Hatter, and Queen. We want to figure out visually where do those things occur in the book Alice in Wonderland. So one thing we can do is we can take the Alice object that we defined above, and we can say dot dispersion plot. Now we're getting into something which is specifically NLTK focused, and we can give it a list. And the list consists of the words that we want to determine the dispersion plot for. So we give it the words Alice, Rabbit, Hatter, and Queen. Let's go ahead and run this thing. And if we do that, we should see a plot here. And this gives us the dispersion plot for those words that we were concerned about. So on the y-axis, we have Alice, Rabbit, Hatter, and Queen. And then basically these little lines, or these blocks, depending on how frequent the occurrences are, tell us where in the story we see these names. So this, the far left part of the axis is the beginning of the book, and the far right of the axis is the end of the book. And we see that the word Alice is used pretty much predominantly throughout the entire text. The White Rabbit, which is a well-known character in Alice in Wonderland, shows up in the beginning and then also near the end, which is, if you've read the story, makes sense. The Mad Hatter has two very well-known kind of prominent scenes in the book, and the Red Queen doesn't really appear until the end of it, so that makes sense why the Queen isn't really mentioned until near the end of the book. So it's kind of a nice visual way to get a bit more information about a piece of text, and the comment below just kind of says a little bit more about that. It just says that, of course, Alice is used consistently throughout the book because she's the main character, and the word Queen makes sense. It's found near the end of the plot because you don't hear about the Red Queen in Alice in Wonderland until near the end of the book. So sorry for any spoilers. So let's move on here. So another thing that we can play with is something called a frequency distribution, and this is something that NLTK provides to us. So this frequency distribution object is something we can kind of query and ask a number of questions. So basically this is going to be some question of the form, what are the most frequent words, or specifically tokens, that are used in a given text? And one example might be, let's generate a plot in this case, because it's a bit more visual and nice to look at. Generate a plot that gives us the most frequent tokens in Alice in Wonderland. So the first thing that we can do is we can generate a frequency distribution object in NLTK. The way that we do that is we just define a variable here, which I'm just going to call fdist, and I've set that equal to nltk.freqdist, and I'm going to pass it the Alice object, which is an NLTK text object. So fdist is now a frequency distribution object, and we can use that to ask it certain questions about the distribution of words in a piece of text. So for instance, let's take this example here. We want to figure out what are the most, let's say 50 most common words in Alice in Wonderland, and let's plot that and let's see what we get. So this line here, we're going to say fdist.plot, and this is the number of terms that will be present on the x-axis. We want it to be cumulative, and we're just going to give it a title of the 50 most common words or tokens in Alice in Wonderland. So let's go ahead and write that and run it. If we do that, we'll see this plot here. So again, on the x-axis we see all of the words, and the y-axis are the cumulative counts of those words. Now, one thing that's a little bit, I guess, not so interesting about this particular plot is we see things like punctuation and words like the and to, in words that would be fairly common in just about any other book that you would read. So you don't really get a whole lot of information in just this plot about the words that are present in Alice in Wonderland that make it unique. You get a lot of very general words that are present in the majority of English text. So what we're going to do for a little bit is try to kind of pare that down and figure out a better way to get a little bit more information-rich content out of this frequency distribution plot. So let's go ahead and comment these things out here just so we don't have them plotting every time. And this comment here is basically just elaborating a little bit more about what I said, is that the x-axis consists of these things that are not necessarily so useful. So let's go ahead and filter, at least for this time, the punctuation out of the frequency distribution. And we can treat that as a dictionary, because fdist, the object, is really just kind of a frequency distribution dictionary-like object. So what we're going to do, let's just focus on what's in this function here. So what we're doing is we're just looping through word and freq in this fdist.items. So the .items pattern should be familiar to you if you know how a dictionary works in Python. And basically what we're doing is we're just iterating through the items in this dictionary-like object, and we're saying if the item that we're iterating over, specifically the first item, so there's always the key value pair in a dictionary. So if the word, which is the first thing that we're iterating over, is something that is alphabetic, namely it's not a punctuation character, keep it. I don't want to see any things that are periods or commas or question marks or anything like that. We'll just ignore those. So if the word is alphabetic, keep it, otherwise ignore it, and then basically store that in a dictionary object. And then the final part here is we're wrapping that all in this freqdist function, which NLTK provides, and we're saying convert the resulting dictionary with all of this punctuation filtered out and convert it to a frequency distribution, and then store that new frequency distribution in this variable called fdist_nopunc. So now we can also treat this, since it's just a frequency distribution as we saw before, and we can plot it just as we did before with the initial frequency distribution. So same parameters here, a little bit of a different title just to kind of distinguish it from the previous one. So if we go ahead and run this, we'll see a little bit more of a helpful frequency distribution. So you'll notice that on the x-axis we have no punctuation, which is good. But we still have some of these other things which are not so useful to us, namely the words the and to, again, very common words that are not so interesting from what makes Alice in Wonderland unique from the words that it uses perspective. So we can also filter out this information as well in a similar way to what we did with the punctuation. So specifically, one of the things, I guess this comment is more or less just elaborating on what I just said, but one of the things that we can do to do that is to focus on something called stop words. So stop words are basically just very common English words like and, the, in, these things that don't provide too much information-rich content into what makes a piece of written work unique. So what we can do is NLTK provides to us a way that we can determine what the stop words in a particular language are. So I'm defining this variable called stop words, and I'm using this stop words function, and I'm saying, okay, give me all of the stop words that are present in the English language. So let me just go ahead and print stop words out so you can see what this consists of. So actually I'm going to comment out this here so we don't have this plotting before. Let me just write that. So let's go ahead and take a look at what the stop words are. So we're going to see a list. So we see like we, our, ours, you, him, he, words that don't really provide too much information. So these are considered stop words in the English language. So I'm just going to get rid of this print statement. So we're going to do a very similar thing to what we did with the punctuation. Is we're going to do, well, I guess pretty much exactly the same thing. We're going to create a dictionary object, loop through. We also have this condition that we had before where we're checking if it's alphabetic, we're keeping it. And if the word that we're iterating over is not in stop words, so if it's not in that list of stop words that we don't necessarily care about, create this dictionary object based on those two criteria, convert it to a frequency distribution, and then give me a new frequency distribution object which has no stop words and no punctuation. So now, if we plot this, we'll get something that's a little bit more useful. So now we have this more interesting plot where it's, maybe it's not quite perfect, but we have some words that are a little bit more, I guess, familiar to the Alice in Wonderland text. Alice looks like it's hard to read there, turtle, rabbit, things like that. So we have queen right over there. So we have, maybe I didn't even see rabbit, but we have some words that are a little bit more relevant to the text itself, and this plot is maybe a little bit more meaningful from that perspective. So I'm just going to go ahead and comment this out, and I believe that is the end of this particular tutorial. So if you like this content, if you'd like to see more of it, if you have any feedback or anything else, I'm happy to hear any feedback, of course. So thanks again for watching, and I look forward to the next video. Cheers.